This is a rotary bean conditioner. It's a fairly heavy unit weighing some 200 tons. It has been operating for several decades with oil spray on the tires. This practice was discontinued 3 months ago with the installation of a thrust monitoring system. With perfect alignment, the oil is no longer needed. Seen here mounted on the wall is the thrust monitor control panel. Each of the rollers has a string of lights. Green indicates normal thrust load to float the drum. A white light means the roller is in its neutral skew position. Amber indicates elevated thrust loads, and a red light means high load or reverse skew. Shown here is a typical thrust sensor mounted on the fixed bearing of each roller. There are 5 sensors, one for each carrying roller and one for the 2 thrust rollers. 3 months ago, the oil was cleaned from the tires and rollers. With alignment now assured to be correct, the rollers and tires are polishing up and are acquiring the hard, polished, glass-like sheen characteristic of excellent alignment. Further confirmation of excellent alignment is seen at the downhill thrust roller. For 3 months now, it's been skipping contact for about a quarter of each tire rotation. Since this particular tire is not migrating, you will notice that the thrust face of the tire goes from a polished surface to a dark, dirty surface in the area where the thrust roller stops and loses contact. This loss of contact is simply due to tire wobble, a phenomenon that is always present on every unit. In the control room, this change of pressure on the thrust roller caused by tire wobble is seen as a near-perfect sine wave. The flat spots in this pressure wave reflects the loss of contact between the thrust roller and the tire. This is a look at the full screen on the dedicated thrust monitor PC that sits in the control room. Center right, we see a mimic of the face of the control panel that we saw outside alongside the conditioner. Immediately on the left of the LED display are the graphs showing the individual roller thrust loads in real time. The timeline window is currently set to an hour. All the thrust loads show a constant level because the signals are averaged over a 3-minute period. This eliminates the tire wobble cycles. Now we have reduced the timeline window to 3 minutes, and we have also removed the averaging filter on 4 of the 6 rollers. It's interesting to note that the tire wobble is not just seen on the thrust roller. Even the carrying rollers actively respond to tire wobble. For half of each rotation, the rollers are pushed uphill, and for the other half, they are pushed downhill. Although this is interesting to observe, it does make it difficult to balance the thrust load across all 4 rollers without the averaging filter. Because of these large swings due to tire wobble, we also see the lights cycling in response. The thrust monitor program has a second password accessible screen wherein light thresholds, alarm levels, and data file archives, among other things, can be managed. The system automatically records all data in 1-hour files for an indefinite period of time. 1 year's worth of files, for example, will require only about 250 megabytes of disk space. The averaging filter has been restored, and slowly over a period of a few minutes, the signals will settle in once more. Operating with the thrust monitor reduces wear on the rollers and tires to an absolute minimum and reduces the load on the bearings to a minimum, allowing you to get the full B10 life out of the support roller bearings. The thrust monitor and trunnion roller alignment via dynamic thrust balancing using the thrust monitor is patented technology only available from Phillips Kiln Services Limited. Contact us for more information.